Hello everyone, thanks for joining my talk today. I'm Yuan from Inclusive Interaction Lab at UCMersat. I'll be presenting our work, WristFlick Design and Evaluation of Smartwatch-Based System for Interacting with Smart Televisions. And I'm sorry that I'm not able to join the conference in person, but I'm still super excited to be here virtually and share our research. So let's dive in. Smart TVs has become incredibly popular, enabling users to access a wide range of digital content through streaming services and online platforms. The market is booming, growing over 200 billion in the last 2 years and projects reaching nearly 280 billion by 2028. As televisions has evolved, so have their remotes. Modern remotes now offer features like voice commands and gesture-sensitive trackpads. However, despite these advancements, traditional button-based remotes still dominate, and they come with challenges. They are often inefficient for media control, menu navigation, and text input for searching queries, especially on today's complex grid layouts and on-screen keyboards. These remotes are also easy to misplace and are not ideal for households with multiple users. Voice and gesture controls, while promising, often struggle with reliability. Furthermore, users can get tired of holding the position, pointing position, or performing mid-air gestures for long periods. And finally, it's sometimes slow in responses because of using the IR technology, leading to user frustration. This is where smartwatches offer a compelling alternative. They are wearable, always within reach, and enable intuitive interactions without needing to fumble for buttons or aim at the TV. Plus, it also allowed multiple people to use their own personal devices to control the TV independently. So, we designed WristFlick, a comprehensive system that enables users to control their smart TVs through a smartwatch, covering menu navigation, focused content exploration, and search. We first conducted a pilot study to investigate the different interaction modalities on smartwatches, including directional flicks, wrist gestures, taps on screens, and force-based interaction approaches. The goal was to determine ideal interaction modalities that could be integrated into a comprehensive system for controlling smart televisions. We used the Fossil Gen 6 smartwatch in our study. It features 2 configurable push buttons and a rotating crown as the home button. We also used an LVPAL G9 remote as our baseline, and the Chromecast running the Android TV OS, and the TV itself was a 65-inch LG display monitor. We used the same devices across all stages of development and user studies. We measured performance using 2 key metrics. The task completion time is the average time in seconds, and the error rates, that is the average number of errors made when they're performing an action. The result shows that tap and directional flicks are significantly faster than force and wrist tilting. It also shows that the force-based method had a significantly higher error rate, while other methods were comparable, and all participants preferred tap and flicks methods for their speed, ease of use, and lower error rates. Notably here, the flick method stood out as it does not require expressive physical action or precise target selection, making it more accessible than other methods. Based on these findings, we designed WristFlick using taps and flicks to enhance efficiency and user-friendliness. WristFlick was designed as a comprehensive system that allows users to control the television without interrupting the flow of watching. It offers 3 distinct interaction modes: media control and navigation, exploration of focused content, and streaming and searching across the TV and streaming services. And the focus content feature here is inspired by the Amazon X-ray. The goal is to create a system that feels seamless and natural, enabling users to interact without breaking their viewing experience. Upon launch, WristFlick connects to the television using a client-server protocol over a shared Wi-Fi network and activate the navigation mode. Users can navigate streaming services by flicking up or down to go through categories. Once the desired category is highlighted on the TV, users can flick left or right to scroll through available titles. And to select the title, they simply tap anywhere on the screen. After selecting the title, WristFlick automatically switched to media control mode. Here, user can pause and play by tapping on the screen. Fast forward by 5 seconds with a right flick, and rewind by 5 seconds with a left flick. For longer jumps, they can flick and hold to progressively fast forward and rewind. Volume adjustment are via rotating the crown. Turn it up, increase the volume by 1 unit, and turn it down, decrease the volume by 1 unit. Here is a short demonstration. The person in the video is performing different actions with the smartwatches for navigation and media control, and the playback is shown at 2 times the speed. You may also notice that the system supports flexible interactions. User can either go at the smartwatch or focus on the TV while controlling the media. While watching media, users can activate focus content exploration with a simple 2-finger tap on the screen, on the smartwatch screen. This action brings up a list of focus content like cast information, trivia, or soundtrack details directly on the television screen. Once in the focus content mode, user can flick left to view the previous item and flick right to go to the next one. Tapping the screen reveals the detailed information, and tapping again closes the details and returns to the list. Here is a short demonstration. The person is performing different actions to explore the focus content from the movie. WristFlick also supports search through handwriting system. User can write characters directly on the smartwatch display, one at a time, to search for media. A letter is recognized when user lifts their finger. To delete a letter, they flick left, and to add a they flick right. And they can perform directional flicks to navigate through recommendations and search results. We built this feature using a 2D gesture recognizer optimized for rapid prototype. Our goal here wasn't to develop a general-purpose text entry system or integrate language model. Instead, we focused on a system-specific solution for media search that leverages the TV's built predictive search functionality. Due to the copyright restriction, we were unable to use the full movie in our system. Instead, we downloaded 10 to 15 minutes publicly available clips of these films. The movie titles were selected to represent a diverse mix of classic, critically acclaimed, independent, and blockbuster films, as well as the 12 most popular movie genres. And the following performance metrics were calculated for all sessions. The task completion time is the average time to complete a task. The action per task is the average number of actions, including taps, flicks, and crown rotations. And task efficiency refers to the ratio to the ideal number of actions to complete a task to the actual number of actions that user complete a task. For subjective feedback, we use the following questionnaire at the end of the study to assess the WristFlick's usability and participants' engagement with the system. We set up the experiment in the lab to resemble a typical living room by placing a couch and a side table. The television was mounted on the TV stand with a rolling cart, 90 cm above the ground and 360 cm from the couch, to ensure an optimal viewing angle. In session 1, we compared media control and navigation performance with WristFlick and the traditional remote. We had multiple experimental tasks, and each task required performing these 9 specific actions. And these actions are carefully selected to ensure all key features of the system are covered. And you can see the task including like a variety of scenarios, such as finding the titles or adjusting the playback progress. We recruited 20 participants for our final study across 2 interaction methods and 12 experimental tasks. The result revealed a significant effect of method on task completion time, action per task, and task efficiency. On average, participants completed media control and navigation tasks 5% faster using WristFlick compared to the traditional remote. And this is surprising given the participants' familiarity with remote control. It also required 9% fewer actions, and participants were 24% more efficient using WristFlick compared to the remote. A deeper analysis revealed that this advantages was largely due to the participants repeatedly pressed buttons on the remote instead of using the press and hold functionalities. This behavior stemmed from their concern about overshooting with the remote while they felt more confident using WristFlick, contributing to the better performance. The session 2 focused on comparing WristFlick's performance in accessing and acquiring focused content with that of the traditional remote. It followed the same procedure as the previous session. And here is a brief session information. The results revealed a significant effect on task completion time and task efficiency, and there's no significant effect was found for action per task. On average, participants completed the focused content task 16% faster using WristFlick compared to the remote, and they were about 2% more efficient using remote. And the post-study debrief suggests that this was primarily because many participants were unfamiliar with the focused content feature, which is available only on Amazon Prime Video, known as the X-ray. And this unfamiliarity led to confusion and errors due to the task. However, despite not knowing, they performed better with our system. Session 3 compared the search performance for both methods. The results revealed a significant effect of method on task action per task, and no significant effect was found on the others. On average, participants performed 62% fewer actions for search tasks with WristFlick compared to the remote. And further analysis reveals a learning effect with both methods. Participants' task completion time were significantly faster in the final block compared to the first one. And you can see, since the learning curve here are not yet flattened, it's unclear whether further practice with WristFlick would allow it to surpass the performance of the remote. Although the focus of this content was not to evaluate text entry performance, we recorded commonly used text entry matrix, words per minute, and corrected error rate for both methods. And we observed a similar trend in text entry matrix. Results showed that entry speed with WristFlick was significantly faster in the final block compared to the first, whereas no such effect was observed for the remote. We found a significant effect on corrected error rate as well. On average, participants corrected 0.61% of the errors with the remote and 18.62% with the WristFlick. And further analysis showed that participants were corrected significantly fewer errors with WristFlick in the final blocks compared to the first one, while no such effects was observed for the remote. The subjective results reveal a significant effect on both perceived speed and willingness to use for WristFlick than for remote. And these are positive results, and they could suggest that a new approach like WristFlick was as easy to learn and use as a commonly used everyday device. Furthermore, participants also rated WristFlick significantly higher on flow than the conventional method, and this suggests that our aim of not disrupting the flow of watching was achieved. In conclusion, WristFlick is an effective alternative to traditional remote for controlling media on television, offers significant improvement in terms of speed, efficiency, and overall user experience. And that concludes my presentation. Thank you. And please visit our social media for more questions in the future.